Okay. An amusement park ride called the Loop de Plane consists of a car that is held by a stiff strut connected to an axis. A counterweight in black helps steady the car's motion. The mass of the car is 500 kilograms and it is at a fixed distance of r equals 10 meters from the axis. So 3.1, which I got a few points off of, was when the car reaches the bottom of the ride, it has a velocity of v is equal to 10 meters per second in the x direction. What is the force exerted on the strut on the car at that position, given that the F net parallel is equal to 0 at that instance? So in terms of actually going about solving this problem, first thing we want to make sure is we want to write down the values that we have. So for example, we have velocity here in the x direction, right? So it's 10, 0, 0 meters per second. We're at the bottom. And F net parallel is equal to 0. Okay. So the correct approach that we want to go about here is we know that the car needs centripetal acceleration pointing upward, which is towards the center of the circular path. And so the weight in this case, right, it would be Fg, 0, negative mg, because it's only in the y direction, 0, which is equal to 0, negative 4900, 0 newtons downwards. And the strut force is upward, which is along the strut. And the net force must provide the centripetal force, right? So we have F net is equal to the force minus mg, which is mv squared over r. So force is equal to mg plus mv squared over r, which is 500 times 9.8 plus 500 times 10 squared over 10. So the force here is 4,900 plus 5,000, which is, 9,900 newtons. So that is the strut force that is upward, all right? And for the second part of the problem, let me read out the question. The car swings and reaches the top of the ride. At that instant, the velocity is negative 1 meters per second in the x direction. What is the force F exerted by the strut on the car at that position, given that F net parallel is equal to 0 at that instant? All right, so for this question, my mistake was I got force is equal to 50 newtons, but I had an incomplete expression here. So the correct approach is, again, we want to find the weight, but we know this from the previous problem that Fg is equal to 0, negative 4900, 0 newtons downward. And we know that F plus mg is equal to mv squared over r, which was also the expression we used last time. So the force is equal to mv squared over r minus mg, which is equal to 500, 1 squared over 10 minus 500 times 9.8. And we use 9.8 because of the acceleration on Earth. So the force here is 50 minus 4900, which is equal to negative 4850 newtons. So this means that the strut is pushed upward, right? And so if we are looking at it radially from outward of the center, we have the force to be equal 0, 4850, 0 newtons. Thank you so much.